Hello everyone, welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry at this platform. This is our chemistry gate syllabus which is compulsory. These are the topics that we have covered till now. So without any further delay, let's begin our topic, that is S block elements. So the S block elements of the periodic table are those in which the last electron enters the outermost s orbital. And S block elements consist of group 1 and group 2, or you can say group 1 and group 2 belongs to the S block elements. As group 1 and group 2 elements have only s orbital, so they can accommodate only 2 electrons in their outermost shell. And group 1 elements are known as alkyl metals, while group 2 elements are known as alkaline earth metals, and the exception is beryllium. As you can see here, this is group 1 and this is group 2. Group 1 elements are lithium, sodium, potassium, rubidium, cesium and francium. And group 2 elements, exception beryllium, as you have seen here, while group 2 elements are known as alkaline earth metal except barium. So the main thing is beryllium is a group 2 element, but it is not considered as alkaline earth metal. And in group 1, as you can see here hydrogen is written, but hydrogen is a notorious element and its position is not fixed yet. That's why you will not conclude hydrogen as a group 1 element. Now this is a general overview about the S block elements. Group 1 elements consist of lithium, sodium, potassium, rubidium, cesium and francium. Group 1 elements are known as alkyl metals. This is important to note that group 1 elements are known as alkyl metals. Why these are known as alkyl metals? Because they form hydroxides on reaction with water, which are strongly alkaline in nature. Group 2 elements are known as alkaline earth metals. This is your group 2 and these are known as alkyl earth metals. The group 2 elements are known as alkaline earth metals because their oxides and hydroxides are alkaline in nature, and these metal oxides are found in Earth's crust. This is also very important, that where the group 2 elements can be found, and these can be found in the Earth's crust. The oxides of these metals can be found in the Earth's crust. Next is the group 1 element. So basically, first of all, we will study about the group 1 elements, their physical property, their chemical properties. Then we will move forward to the group 2 elements. First of all, we will complete the group 1 elements. So in group 1 elements, if we talk about sodium, potassium, rubidium, etc., among the alkyl metal, sodium and potassium are abundant. Means they are found in very high ratio in nature, that is sodium and potassium. While lithium, rubidium and cesium have much lower abundance in nature. Francium is highly radioactive. Question can be asked, in S block elements or in group 1 element, which element is radioactive? And the correct answer is francium. Francium is the highly radioactive element. And francium has the half-life of only 21 minutes. You have to remember this point, that francium has the half-life of only 21 minutes. And cesium is present in its liquid state. Next is the physical properties of group 1 element. First of all, we will study about the physical properties of group 1 element. Then we will move forward to the chemical properties. So let's learn about the physical properties of group 1 element, and number 1 physical property is the physical state. The group 1 metals are silvery white, means they are the color of silvery white. Light, soft, malleable and ductile. This is the property of group 1 element. The atom of group 1 elements is paramagnetic. You have to learn this point. The atom is paramagnetic, while the ion of S block element of group 1 element is diamagnetic. You have to remember this point. Keep in your mind that group 1 element's atom is paramagnetic, while the ion of group 1 elements, that is sodium, potassium, lithium, cesium and rubidium, is diamagnetic. Its ion is diamagnetic. Next is the atomic size. As you move forward, as you move along the group from top to bottom, the atomic size increases from lithium to cesium, while the third property, melting point and boiling point, decreases when you move from top to bottom along a group. Melting point and boiling point of lithium is maximum, while cesium has the least melting point and boiling point. Fourth point is ionization energy. Lithium, sodium, potassium, rubidium and cesium, when you move along the group, atomic size increases and ionization energy decreases, because you know ionization energy and atomic size has a inverse relationship. That's why the size of lithium is very small and the ionization energy of lithium is very high. And in case of melting point and boiling point, weak interatomic bonds are there due to the large atomic radii and presence of only one electrons. Hence, melting point and boiling points are the low. And this is the decreasing order of melting and boiling point. Next, we have the metallic character. Metallic character is inversely proportional to the ionization energy. And when if ionization energy decreases along the group, then the metallic character will increase along the group. Next point is the density. In a group, atomic volume also increases along with the atomic weight. But atomic weight increases more than atomic volume, so density increases from lithium to cesium. I repeat, in a group, atomic volume also increases along with atomic weight, but atomic weight increases more than atomic volume, so density increases. But there comes an exception, that density of sodium is higher than the potassium, as empty d orbitals are present in potassium. Maximum capacity of M shell is 18 electrons, but it contains only 8 electrons, which decreases its density. Increasing order of density will be the increasing order of density will follow this trend, that is lithium, then potassium, then sodium, then rubidium, and then cesium. Now, the order of conductivity. Due to the presence of loosely held valence electron, which are free to move in a metal structure, these elements are good conductor of heat and electricity, but the conductivity of group 1 elements is less than the group 2 elements. Next is the flame test. Alkyl metal and their salts give characteristic color to Bunsen flame. The flame energy causes an excitation of the outermost electron. which on dropping back to the ground state emits and absorbs energy as visible light. For example, lithium gives crimson red color, sodium gives golden yellow color, potassium gives violet color, rubidium gives red blue color, and cesium gives blue color. Now talking about the photoelectric effect. When you talk about the photoelectric effect, atomic size of potassium, rubidium and cesium is quite large. So their ionization potential is very low. Due to very low ionization potential, their valence shell electron get excited even by absorbing visible light. That's why potassium, rubidium and cesium are used in the electric cell, while lithium and sodium do not used in the electric cell, and lithium and sodium do not shows photoelectric effect. This is rubidium. This B should be small, RB. Next, standard reducing potential. All the alkyl metals have high positive value of standard oxidation potential. Standard oxidation potential means tendency to release electron in water or self-ionic solution. So these are the good reducing agents having uppermost position in the electrochemical series. And this reducing strength is inversely proportional to the standard reducing potential. When you talk about the aqueous condition, lithium has the highest reducing strength, while due to the high hydration energy, while in gaseous state, cesium has the highest reducing strength. Next is the complex formation tendency. Only those elements will form complex which have the small size and the high charge density. In case of group 1 elements, only lithium will form a complex due to its small size, and rest alkyl metals have very less tendency to form complex compounds. Next, we are going to discuss about the chemical properties of group 1 elements. Number 1 is the reactivity. If you talk about lithium can only react with steam, while sodium, potassium, rubidium and cesium reacts with cold water. And if you talk about the reactivity, when you move along the group, reactivity will increases. Group 1 elements are more reactive than the group 2 elements. Next is reactivity with air. On exposure to air, these get tarnished due to the formation of oxide. To prevent tarnishing on the surface, so these elements are stored in kerosene or paraffin wax. With dry air, lithium forms both oxide and nitride, but rest all the elements only forms oxide. This is very important point. Lithium forms both oxides and nitride with dry air, while rest all the elements will form oxides. In moist air, they also form carbonates. In case of moist air, the elements of group 1 will form carbonates. Reaction with O2. If you talk about the reaction with O2 of the group 1 elements, oxide can be of 3 types. Number 1 is normal oxide, which can be represented as O2 minus. O minus 2. While peroxide can be represented as O2 minus 2, while superoxides are O2 minus. The order of size is superoxides has the maximum size. If we talk about the size order, superoxide has the maximum size and the least size is for normal oxide, that is your O-2. Next, lithium can form only oxide. You have to remember this. Lithium will only form oxide while sodium will form peroxide in excess of O2, and potassium, rubidium and cesium can form superoxide in case of excess of air. Superoxides are paramagnetic and colored, and the stability order for the oxides, peroxide and superoxide is this, that the stability order of oxide is maximum and superoxide is minimum. And superoxides are used by space travelers because superoxides can absorb carbon dioxide from oxygen. Next, reaction with hydrogen. All the group 1 element forms ionic hydride with H2, and the formation of ionic hydride will be represented as this. Here M represents the metal or the element of group 1 element. When you put the value of M, means when you interchange the M with any group 1 element, you will get the result as this 2M plus H minus with H2 reaction. On hydrolysis, when you hydrolyze this compound to M plus or H minus, you will recover the H2 gas, and the compound will form as MOH type. M represents the metal or the element. In place of M, you can put lithium, sodium, potassium, any metal of group 1 element. Next, reaction with water. Group 1 elements react with water to form MOH type compound. When metal of group 1 is reacted with H2O, the forming species will be MOH type and half H2 gas will be released. Next, reaction with halogen. These forms MX type metal halide. Group 1 element forms MX type metal halide reacting with halogen. And as you know, halogens are the group 17 elements. In place of group 17 elements, in place of X2, you will put the fluorine, chlorine, bromine, etc. And the forming species will be M plus X minus, that is MX type metal halides. Next is the carbonate formation. Group 1 element forms the M2CO3 type carbonates, and in case of nitrate formation, MnO3 type nitrates will be formed. On heating, when you have the MnO3 LiNO3 type nitrate for lithium, when you heat this LiNO3, you will get the compound as Li2O, that is your M2O type compound. While if you heat another elements except lithium, you will get MnO type compound. Here you are getting M2O type compound, while for rest of all the elements you will get MnO type compounds. Next is formation of amalgam. All the elements, all the metal of group 1 will form amalgam with reacting with Hg, reacting with mercury. Now this is the very important point, solubility in liquid ammonia. All first group metals are soluble in ammonia and forms deep blue solution, which is conductor and reducing due to the presence of free electrons. All the elements of group 1 are soluble in ammonia, in ammonium solution, and forms the deep blue solution. Question can ask, what is the color of ammonia solution? This is your deep blue color, which acts as a conductor. Why it acts as a conductor? Due to the presence of free electrons. Next, when after some time the solution becomes light, due to the amide formation. And if you mix ammonium salt in that solution, then it will become colorless due to the formation of NH3. You have to remember this point because question could be asked in this from this point. If you add ammonium salt in the solution, that it becomes colorless. Why it becomes colorless? Due to the formation of NH3. Now I hope you are cleared about the physical properties and the chemical properties of group 1 elements. And in next lecture we will discuss about the group 1 elements, group 1 compounds. Now if you are new here at this channel, you can like, share or subscribe. The channel is Gurmantra Shiksha Ka Granth. You can also join our Telegram channel, that is Gurmantra. And for further queries, you can mail us or contact us, and the information is given to your screen.